Okay, so suppose I tell you I have a polynomial, ax squared plus bx plus c. A quadratic polynomial. So that quadratic means it's only the highest one is x squared.
Yep.
Okay. And I'm going to fill in some values for it, but I only know these three. So just give me a number, f of 0, just tell me a number. I'll make it an integer, but it can be positive or negative.
Like 4.
Okay. How about you tell me what f of 1 is?
How about 17?
Okay. And f of 2?
Like 25.
25. Okay. And it's going to turn out there's only one quadratic polynomial that satisfies this equation. So that has these three numbers. And we can find it using this difference method. So the first thing I can do is take the difference. 17 minus 4 is?
So 13.
25 minus 17?
8.
8. And 8 minus 13?
Minus 5.
So here I don't know, so I just have to leave this blank. And then my delta squared is minus 5. Okay. Now remember the deltas with quadratics were 2 when the leading coefficient was 1.
Yep.
So what does that mean the leading coefficient here is?
So, I guess it's so 2 to 1 is minus 5 to something. So maybe minus 5 halves.
Okay, that's right. That's actually very good thinking too. You did the ratio. 2 is to 2. The leading coefficient of 2 is to 1, which is the delta squared of 2 is to 1. The leading coefficient, as minus 5 is to the thing we're looking for. So the thing we're looking for is minus 5 halves. So that tells us that this f of x equals minus 5 halves times x squared plus bx plus c.
We can see how we can find c.
Okay. I know you can. Can you see how we can find c here? Is there an easy way that we can learn what c was?
Well, C would be just a number you'd be adding to C is, well, we found the C didn't really matter what it was in the previous.
It didn't factor into these deltas.
Yeah.
So how do we find c really quick?
So f of 0.
Okay, if I plug in 0, I get 0 times a plus 0 times b.
So that would be negative.
0 times a is what?
This is 0.
0 times b is?
0.
So what does f of 0 equal?
It's just C.
It's just c. So what is c?
C would be 4.
C would be 4. So just from observing the delta squared, we get minus 5 halves. From observing what f of 0 is, we get c. And now we're just trying to find b. So how do you think we can do that?
We can plug in any one of these.
Okay.
I guess not 0, because it's not going to tell us anything.
Right.
So let's plug in, we can plug in 2.
Okay. I have to give myself some room by erasing these deltas. So f of 2 down here, from our chart we know it's 25. From down here we know it's...
So minus 10, because minus 5 halves times 4.
Okay. So minus 10.
And plus 2b.
Is that right?
Yeah.
Or not? Okay. Minus 10 plus 2b plus...
Plus 4.
Plus 4, and this has to equal 25. Right?
Yeah.
So 2b minus 6, 25.
So 2b is 31.
Which,
So b is 31 halves.
Okay, so we've just figured out 1 halves. Minus 5 halves is x squared plus 31 times x plus 4. And the only way left we have to check this, that this is right, is by using the only one we haven't used yet. Is 1. Let's just plug it in. Can you tell me what f of 1 is?
so
Hopefully we're going to get 17. But what do we get from plugging 1 into this equation?
So we have 5 halves. So 5 halves plus 31 halves.
Not 5 halves.
Negative 5 halves.
Negative 5 halves.
Plus 31 halves.
Plus 31 halves.
And plus 4.
Plus 4. So what is this?
So 26 halves plus 4. So 13 plus 4 is 17.
Yeah. So isn't that interesting?
Mm-hmm.
So if I give you 3 coefficients, or 3 numbers for the polynomial, then I tell you the polynomial is a quadratic. Using this difference method, you can actually solve it. Find out what it is. That's pretty neat. So polynomials are pretty cool. They have lots of fun and interesting properties, and you'll be studying them a lot next year, and probably already have a little bit, right?
Yeah.
And you're just starting to learn about them.
Yeah.
That was good. Good work, guys.